give reasons. Concentrated nitric acid can be transported into aluminium container. Can aluminium react with nitric acid? Actually it does, but there's a catch. And what is that catch? Concentrated nitric acid passivates aluminium. What? Yes, aluminium is passivated by concentrated nitric. Please note, this is not true for dilute nitric acid, but concentrated nitric acid can be passivated by aluminium. What happens? As aluminium is treated with concentrated nitric acid, immediately aluminium is oxidized. There's a very vigorous reaction. Lots of heat is generated and nearly immediately the reaction stops. What happens is a protective coating of Al2O3 is formed on aluminium metal. The surface of metal is covered by a very thin coat, but a protective coating of Al2O3 which sticks to the surface. And that, my dear, prevents the further reaction of aluminium with any remaining nitric acid. And that is why you would find that aluminium does not react with nitric acid. As a matter of fact, it is passivated by nitric acid so well that after passivation, even if you add dilute nitric acid or other acids, aluminium would not react with any other acid as well. Fantastic. A mixture of dilute NaOH and aluminium pieces is used to open drains. You would find that there are drains which get choked. A lot of different stuffs are often drained out, and sometimes there is choking. Choking means something is stuck within the pipes and somebody actually has to go and push them, and there is no way you can actually go inside a pipe and push it. So, and that's very gross and dirty idea also. So what happens is, if you take aluminium and if you add dilute NaOH, something wonderful happens. Slowly, as they are washed down the drain, they react. And when they react, they release hydrogen gas. First of all, NaOH itself is capable of reacting with any remaining oil or grease. So it can cut through oil and grease, and that helps. Not just that, when hydrogen is generated, it is a gas, it needs a lot of volume. But it is already present in the drain, it is liberated within the drain. So that gas pushes any kind of junk or any clogging material which is choking the drain. So as that material gets pushed, the drain gets cleared out, and this is what we need. So this is why the mixture is used. Graphite is used as a lubricant. This is very interesting. Why? Actually, graphite consists of nice, beautiful, happy, hexagonal rings of sp2 hybrid carbon atoms. So what? And these layers and these rings are attached one after the other like this, and they just continue like this. This one flat layer is known by a very beautiful name. This is called graphene. And such one layer above the other, one above the other, that way, if you join, you find when these layers are placed one above the other, they are just attracted to each other by van der Waals forces, very loosely held, and they actually give you your entire graphite. Since these two layers are only held by loose van der Waals forces, they can slip over each other. And because they can slip over each other, graphite is not very hard or rigid, it is very soft. And because of the slipping, at molecular level it can function as a lubricant. Yes. One more very interesting thing about graphite is that graphite has a very, very high melting point, more than 4000 degrees Celsius. What does that mean? It means that graphite as a solid powder, if graphite powder is applied as a lubricant, it would never melt. It would never, and many times, if you apply something like grease as a lubricant, on heating it melts. When it melts, molten grease can just flow away from whichever portion was greased out, and again friction comes back because the lubricant goes away because it has become thinner because of heat. Graphite powder does not become thinner. Thinner means less viscous because of heat, because it is a solid powder. Efficiency of this lubricant does not change on heating, and that is why it is a very beautiful and nice lubricant, except one factor: it cannot be used as a lubricant in open systems. The system has to be closed. Why? Because otherwise on heating, graphite can burn in oxygen to form CO or CO2. If you have closed engines, closed setups where oxygen is not entering, graphite powder is a very good lubricant. Diamond is used as an abrasive. What is abrasive? Something which is hard and rough, which is used for cutting and polishing. I live in Kota, Rajasthan, and that is a place famous for something called as Kota stone. It's a green colored stone. It's a variation of marble. It's not actually marble, it's a different stone, but ultimately it's calcium carbonate only, which has a greenish hue. You would often find Kota stone applied on, used on railway stations, etc. The fun part is, this stone is cut using diamond cutters. And when I, for the first time, observed those cutters, I had imagined something like a Sudarshan Chakra, glittering diamonds placed on one cutter. They were nothing like glittering diamonds. They were very dull black diamonds. They were raw diamonds, and they were black also, because there are diamonds which are not gem quality diamonds, and they are the ones which are used for cutting. But yes, is it used in an abrasive? Because diamond is the hardest known substance which is popular. There are scientists who claim that they have got substances harder than diamond, but very unpopular. Diamond is the most popular, hardest substance known to humans. And that is why it is used for cutting and polishing other things which otherwise are considered hard, like stone. Aluminium alloys are used to make the aircraft body. Aluminium as a metal has very less density as compared to iron. Iron has been very popular because it is sturdy, it is strong. Aluminium as a metal has a good tensile strength, it is a strong metal. At the same time, its density is significantly less than iron, and that is why if you have to fly a plane, flying a plane, a very important component is the lesser the weight, easier it is to fly, and aluminium makes sure that the weight of aircraft's body is much lesser, and that is why it is a very preferred material. Aluminium utensils should not be kept in water overnight. Why? Actually, aluminium can slowly react with water. What? Yes. If you make amalgam of aluminium, it is very much capable of reacting very vigorously with water. Actually, what happens is, aluminium, if just left on its own, can slowly react with water to form aluminium hydroxide. It could liberate hydrogen. So if you have aluminium vessels, aluminium cooker or something, it would get corroded if you have something of this kind. And especially if you have soaps or bleaches, they are alkaline in nature, and they also can dissolve some portion of aluminium or even aluminium oxide coating. So the life of the utensil will be greatly reduced. That is why it is preferred that you just let it rest in dry condition. Aluminium is used to make transmission cables. Why? Because aluminium has a reasonably good conductivity. Electrical conductivity of aluminium is high. Of course, it is not high like copper, silver or gold, but it is much cheaper than copper or silver or gold. Its density is less, the cables have lesser weight, and they are more easily sometimes to hang up and carry around. Most importantly, they are cheap, and at the same time, they are very good conductors of electricity, and that is why aluminium is used for making transmission cables. Good electrical conductivity, less cost, and easy availability of aluminium.